Welcome to week 2 of hazardous waste treatment and disposal. This week we have a little variety with defining basic chemical and physical properties of hazardous waste. Chemistry majors are ordinarily required to take a full year of organic chemistry in college. So this will be a real challenge to cover the highlights of organic chemistry in a few minutes. The textbook does a remarkable job on the basics, but major items to remember for your study of hazardous waste would be the following. Consider whether a bond is covalent or ionic. An ionic bond will usually dissolve in a solvent like water to form a positively charged ion, a cation, and a negatively charged ion, an anion. A cation will migrate to the cathode in a battery, whereas an anion will migrate to the anode in a battery. Ionic compounds tend to be good conductors of electricity when dissolved. On the other hand, a covalent bond, particularly a molecule only composed of carbon and hydrogen, is harder to dissolve in water and may have properties resembling oil. A special term used is the polarity of bonds and molecules. The careful student has to ask if there is any reason why a molecule would want to have a positive or negative charge at one place in the molecule and not somewhere else. These polarities or charges affect the behavior of organic pollutants in natural and engineered systems. A phrase common in the chemical industry regarding solvents and what will dissolve in the solvent is like dissolves like. A very nonpolar molecule like hexane would likely dissolve better in a nonpolar solvent like benzene instead of a polar solvent like water. With organic chemistry, there are almost an unlimited number of ways to make molecules. All these chemical options have led to a variety of ways of naming organic molecules. The three most common ways of naming molecules, nomenclature, are first, following the guidelines of an old and well-respected international chemical organization, the International Union of Pure and Applied Chemists, IUPAC for short. Second, many chemicals have common names used for many years by both professional chemists and the public. And third, trade names often appear in industrial use. Petroleum is a common commodity. Because petroleum is so common, it has tended to end up in places that it doesn't belong. That is, it becomes a pollutant. A key aspect to remember for petroleum is that it is really a complex mixture of hydrocarbons and other organic compounds containing oxygen, nitrogen, and sulfur. A fractionating column at a refinery separates this complex mixture into the major categories that you have heard of commercially: gasoline, diesel fuel, aviation fuel, bunker fuel, etc. The periodic table of the elements was a remarkable discovery based upon a long history of trying to determine how many elements existed and why did they react in certain ways. One of the columns on the right-hand side of the periodic table is the halogens. The halogens contain the elements of fluorine, chlorine, bromine, and iodine, which tend to induce polarity and have very common atoms to bond with the nonpolar carbon chain. This interesting halogen chemistry has resulted in a variety of halogenated solvents that are well known for excellent cleaning properties. Regrettably, these halogenated solvents also produce remarkable hazardous waste properties that always need to be considered. Along with the remarkable cleaning properties of halogenated organic molecules, it probably came as no surprise that many halogenated molecules had excellent pesticide, insecticide, and herbicide potential. This third slide lists additional categories of particular interest to the field of hazardous waste. The organic chemistry of explosives, industrial intermediates, polychlorinated biphenyls, and dioxins or furans are worthy of additional textbook reading. With respect to environmental work and hazardous waste, PCBs are the compound category that has received the most visibility due to the widespread use of PCBs in the utility industry. Nuclear waste can be confusing because the laws, properties, and effects differ significantly from the more traditional organic hazardous wastes. Nuclear wastes are usually elemental and non-organic and are the radioactive isotope of the non-radioactive element. For example, a non-radioactive hydrogen atom may also obtain two more neutrons in the nucleus to become a radioactive hydrogen isotope called tritium. Aspects to consider for radioactive material are how does the radioactivity decay by either alpha, beta, or gamma radiation, and how long does it take for half the radioactivity to decay, the half-life. Health effects are evaluated based upon the radioactive isotope, the half-life, and the energy of the radioactive decay. For example, in operating nuclear power plants, the reactor coolant carries a highly energetic beta decay isotope called nitrogen-16. However, nitrogen-16 has a very short half-life. So a decay loop can be placed in plumbing so that by the time the reactor coolant reaches the chemistry lab for analysis, the nitrogen-16 has all decayed to a non-radioactive isotope. The last slide mentions a number of metals and inorganic nonmetals that possess hazardous chemical properties and need special attention with respect to treatment or disposal. I'm certain you recognize the name of many metals, but always consider that there are items like cyanide and asbestos that could end up on a hazardous chemical list and require hazardous waste disposal.